Hi everybody, you have made it to the home stretch. Just a couple weeks left and you're all done with this course. This is the final review for spring 2019. These are some of the problems that are on the review, not all. Any of the ones that have a correlation to the review paper that I have posted will have the number with the equation. So first one, at the very beginning, 1b, solve each equation. This is important to note only because anytime you have an equal sign, as you can see the equal sign at the top right, you are going to solve for something. In this case, you solve for the missing variable. I chose this one because we always panic when we have fractions. So first thing you're going to do is to get the fractions on the same side of the equal sign to get your variable by itself. So we subtract 3/5 from both sides. We draw our equal sign. Remember, we got to keep the scale balanced. So what you do to one side, you must do to the other. Your a is brought down, and then you have -8/25 minus 3/5. In order to deal with fractions, this is a piece that we didn't really cover, but hopefully you remember from grade school. You have to have a common denominator. And in order to have a common denominator, so the least common denominator, which means you must multiply -3/5 by 5, because 5 times 5 equals 25. The -8/25, you don't need to do anything. It's just the way it is. Once you multiply by 5, you get a -15/25. At this point, you do keep change opposite, so you keep the first sign on the first fraction, you change the equation and do the opposite of the sign for the last, so it becomes a -8/25 plus a -15/25. When you add two negatives together, you add the numerators, keep the denominator, and that's your final answer. Writing numbers in scientific and standard notation. So scientific notation, as you can see on the bottom right, is a number between 1 and 10, and then times 10 to the nth power, which is the number of times you moved your decimal point. If you have a number smaller than 1, which is what we have here, you're going to have a negative power. If you have a number that is larger than 1, you're going to have a positive power. So in order to do this and to put it into scientific notation, I need to move my decimal point until I have a number between 1 and 5. So I moved it over, so I have, not 1 and 5, 1 and 10. I have 5.41. So I take that 5.41 and I times 10, and then I count how many times I moved over. In this case, I moved my decimal point 4 points. So it's a -4 because I have a number smaller than 1. Evaluate tends to be the tricky one people always get hung up on. When you have evaluate, you are not rearranging in any way. There is no equal sign in the original question, which means you are not solving for a variable. All you have to do is plug in what you know. So we have 4x minus 5y squared plus 10, and we know that x equals 2 and y equals -1. So all you do is you take your pieces and you plug in what you know. We know x equals 2, so I have 4 times 2. I know that y equals -1, so I have -5 times -1 squared. I take away my squared, so -1 times -1 is a +1. Okay, I did my math. 4 times 2 is 8. -5 times 1 is a -5, and then I just do my math from left to right. 8 minus 5 is 3, plus 10, 13. I have evaluated this problem. It is not solving. It could be simplifying, but what it is evaluating because you already know your pieces. Graphing on a number line. This is always tricky because in chapter 3 we get through graphing on a 4-quadrant graph and having a slope and all of that. This is actually chapter 2, so we go back to the beginning where you only have an x. On your final, it will always say graph on a number line if a number line is necessary. So what I do is I take this equation and I have to solve for x, so I need to get x by itself. So first I subtract 5 on both sides. 8 minus 5 is a +3. I divide by 2, 3/2. Now your job is to make your life as easy as possible. Now I could get a calculator and I can go 3 divided by 2 and I know it's 1.5. All right, and you can graph from there, or you make your life easy. I draw a number line. Because I have just an x is greater than, not an equal to, it's a parenthesis. and it's greater than, which means arrow to the right, and all you do is label what you have. Make your life easy. This is chapter 2.4, word problem, so 2.4, 2.7. This is the long way to do it with all the pieces, and I'll explain the short way in a minute. So you have your information. Remember, with word problems, make sure you go through and find the important things. We know that Sarah is making $3,200 a month, and she wants a 6% raise. So in order to start, we have to figure out how much her raise actually is in terms of dollars. So in order to do that, you only have two options. When it comes to percents, you're either going to multiply or divide. If you divide 3,200 by 0.06, you get a crazy large number. It's obviously not going to be a 6% raise. So logically, we go to multiplication. So I multiplied 3,200 by 0.06, and I get $192. So that means she gets an extra $192. So my next step is then to add that to the current pay. So then I have 3,200 plus 192 gives me 3,392. So I know her new pay is here. Shortcut version, for those of you who like shortcuts, we know that in a month she's going to get her whole paycheck plus the extra 6%. So what you could do here and skip this second step is you take 3,200 and you multiply it by a 1.06, because that's saying you get one whole month plus an additional 0.06%, which would then give you the 3,392. Graphing the line. All right, there's two ways you can do this. During the videos, I taught you both. You could do a t-chart, you can do slope-intercept form. In my opinion, slope-intercept form is quicker. So looking at this, my goal is to get y by itself. So I can have y equals 3 mx plus b, so slope-intercept form, which means I'd have to add 6 on both sides. When I add 6 on both sides, I end up getting 3x plus 6 equals y. This is the same thing as if it's y equals 3x plus 6. All I did was take the mirror image. There's a whole bunch of steps involved if I wanted to write it out, but in reality, you come up with the same answer. So just flip it so the y is on the left. Once here, I have my graph, okay, and I always start with my b, or my y-intercept, which is always the tail, the piece that's hanging off that's not connected to the x. So I have a positive 6. Now my graph is a little small, but I put my dot on 6. From there, I have a 3x. This is my slope. So I can go from this point and I go up 3 over 1. Because I ran out of room on my graph, I just did the exact opposite. I went down 3 to the left 1. Same concept applies. Because my 3 here is positive, I have a positive slope, so lower on the left, higher on the right, and I'm finished. Equations. So there's a few equations you need to memorize. You need to know standard form, so ax plus by, ax plus by equals c. You need to know slope-intercept form, so y equals mx plus b. Here's another one. You need to know rise over run or slope. Remember, slope is always a lowercase m, so it's the change of y over change of x. All you do is you take your points and you line them up. So I have y2 minus y1 equals x2 minus x1. It doesn't matter up here which one you make x and y 1 and 2. All that matters is that your ordered pair will line up vertically here. So if I put 1 first, my 8 has to go below it. If I put my 5 first, my 2 has to go below it. Vice versa, if I put if I put the 5 first here, then the 2 would go below. Doesn't matter your order, just make your life easy. I do the math across, I get negative 4 over 6, and then I have to simplify to get the answer. If you do not simplify on the final, I cannot give you the points for having the correct answer. An unsimplified answer is not correct. Okay. So then stepping down, number 19, find the slope of the parallel line. So you have y equals mx plus b. Okay, that's your most important. It's in that form, so slope-intercept form. The m is our slope, and if you recall, we talked about parallel and perpendicular lines in chapter 3. Parallel lines, your slope is identical. Perpendicular lines, you have a negative reciprocal, which means you change the sign and flip it from the numerator to the denominator, or vice versa. In this case, it's already since it's asking for parallel lines are identical, so my slope will be identical. My answer is 5. Try not to think too hard. Okay. On the bottom one, it says, write an equation. This is number 20. It's also number 21 is one like this. When you are asked to write an equation, if that's all it says, if it doesn't say write an equation in slope-intercept form or rearrange to standard form, if it says write an equation, you're looking at point-slope form. So y minus y1 equals m times x minus x1. Your y1 and x1 are a point, and your m is your slope. In this case for number 20, I need to figure out slope first. So I will go back to change of y over change of x over here, and I would do the math. When I do the math, it comes out to 2 over 7. I do the same process as up here for these 2 points. I get 2 over 7, and then you can pick the first one or the second one to plug in. In this case, I pick the first one. Doesn't matter. You could change this because you can't have minus and negative. It could be x plus 3 because of keep change opposite, but I will take either grade. Now this is a tough one, okay? Systems of linear equation. This is chapter 4. We didn't spend a lot of time. This one is not correlated to any number because it's really hard to get the systems up on slides. So this is one from the lecture, but the concept is the same. Based on the test you guys took, the graphing and the elimination or addition method looked great. The substitution was the worst. So substitution, number 1, you got to figure out where is a variable that's by itself. So looking, at my 2 pieces, this one already has x by itself. So I know for both of these equations, x is going to equal y plus 4. So I take that information and I substitute it, hint, hint, substitution. I substitute it for x. So then I have 2 y's and I can solve for y. You do the solving just like you've done from the very beginning of the semester. Distribute the 2 across, combine your like terms, subtract 8 on both sides, divide by 5, and you get y equals 1. In this case, I'm not done yet. Yes, I have 1, but I'm looking for an ordered pair. I'm looking for the point where both of these equations touch. So what is that point on that graph? So I have 1, so all I do is I take this y, and I need to bring it back over here and plug it into either one. Well, because I already know y, my goal is to find x, so I'm going to plug it in y and solve. So I plugged it in y, I got y equals 1, so 4 plus 1 is 5. My final answer will be an ordered pair, and you must write your solution as an ordered pair. It doesn't just work if you say x equals 5 and y equals 1. No, your solution is parenthesis 5, comma 1, close parenthesis. Okay, that is where those 2 lines touch. All right, functions. So we talked about functions very briefly in the video previously. With functions, you can have multiple x's, but you can only have one y because your y is dependent. Okay. Any other way, if you look at question 31, it just asked, is the picture to the right a function? This is the moment where it's the easiest moment of your life. All you do is a vertical line test. So you draw a vertical line anywhere on the page, okay, and you ask yourself, does it hit this more than once? Okay. Now for mine, my drawing is slightly different than yours because I had to try my best. So when I drew my vertical line, I actually hit it twice, so I would answer no. For you, when you draw your vertical line on yours, because your mouth here is a lot wider, so when you just draw the vertical line in the middle of the picture, your answer would be yes, yours is a function. Okay.